All right, here we go. We learned how to relative or absolute? Absolute, good. And we decided that they could only occur at one of two places. Absolute extrema can only occur at what type of x values? Critical values, which are values in the domain where one of two things happen. Derivative is 0, horizontal tangent line, or the derivative doesn't exist, cusp/vert, right? Or an absolute extrema can occur at an x value that's known as an endpoint, good, of a closed interval. So now we have the tools for analytically finding them without the graph. So we're going to have another way later on when we get to optimization. So the method I'm teaching you now is called the closed interval method for finding extrema. This is when you know, or when you have a closed interval and you have a function that's continuous on the closed interval, the EVT would guarantee then that if you have a continuous function on a closed interval, that you're going to have both a what and a what? A max and a min, right? By the EVT. If it's a continuous function on a closed interval, you're going to have both a max and a min. And we know they're going to occur at either an endpoint or a critical value. So here's the easy way to find the absolute max or mins for a continuous function on a closed interval. Step 1, identify the endpoint. How hard is that going to be? That's going to be super easy because they're going to actually give you the endpoints. Here they are, and you just have to say, there's one, there's the other. Point to them, exclaim them, whatever. Number 2 requires a little bit of work. We have to identify any critical values. So that's where our work job comes in. We have to go out and find them. The endpoints are already there. The critical values we find. So we're going to take the derivative. We're going to set it equal to 0. We're going to see it's where it's undefined. But we need to make sure of two things. Of course, critical values have to be in the domain of the function, right? So we're going to make sure they're in the domain. But more importantly, we want to make sure also that they are in the specified interval that we're talking about. Because you can get a critical value, let's say, at -7 on a graph, but if you're only looking at the interval from 0 to 1, -7, the critical value, can't play the game. And it is a game that we're playing. There was an example several years ago where a guy lived in New Braunfels. He was in the domain of human beings. He was alive, and he was of age, so he ran for office. And he was running for office for a precinct in which he didn't live. And they only found that later out. So he was like, oh, darn it. You don't live in this precinct, so you can't run. And he's like, okay, then, well, I withdraw my name from the candidate list. So we need to make sure it lives in the specified interval before we can use it. Once we have all the endpoints and critical values identified, then it's time to actually find the y values. So we're going to call it the game of finding the biggest and smallest y values. All you have to do is then plug them into your function, evaluate them, and once they're all in a lineup, then you use your powerful powers of perception to decide which one's the biggest and which one's the smallest. It's that easy at the end, okay? So it will be like playing a game. So we're going to have a game called the biggest y value and the smallest y value contest. And the contestants, to be eligible to play the game, you have to be an endpoint or you have to be a critical value, right? Once you have all your contestants on the stage, then you play the game. And it's the Extrema game. We'll call it Extrema. That could be the name of the game show. Extrema. So, which one of you three guys would like to take this? Read this italicized print in the voice of a game show host. Dawson, you want it? All right, here we go. Hang on. Go ahead. Just hold it. There you go.
Who will be the biggest y value? Who will be crowned the global maximum? Will it be the contestant A, the left endpoint? Will it be contestant B, the right endpoint? Or will it be contestant C, the critical value?
Dun, dun, dun. Very good. Yeah, the audience claps. Wow, who wouldn't want to be? Yeah, nice. All right. Okay, so here we go. These are the 3 players we found for our game. No, it's not a tie. There's a winner and a loser. All right, so we have the left endpoint. That's the redhead right here, okay? We have the right endpoint. That's the creepy guy with what is a tie, okay? That's the creepy tie guy. And then we have the critical value on the interior. That's the yeah, you go girl, okay? And if we let their scores represent the Y values at their X values, then who would be crowned the maximum winner? Creepy tie guy. Okay, he's the maximum winner. So he gets to he gets a prize. I don't know, a pat on the back or a rub on the head. Okay, who gets the absolute minimum prize? The critical value, the you go girl. Okay, and then the redhead. Thanks for playing. Parting gifts. What kind of toaster? A broken toaster. A broken toaster. Okay. It would be a cool game show, right? Extrema. Right. 2 of the 3 people win, and then the other person is gets a broken toaster.
Either how good can you do or how badly can you mess this up?
Yeah, either one. We reward both of them. Okay, but not with the broken toaster. That's if you fall short of succeeding or failing.
But if it's a 3-way tie, then everyone wins.
Depressing. All right, you ready to play the game? Let's play it for real. Okay? Enough of the silly analogies. But great job, Dawson, on the voice. Okay? Example 7. Here's what you're going to have to do. Determine if the EVT applies. And if it does apply, then find the extrema of this function on that closed interval. So, first things first. Does the EVT apply? Do we have a function that's continuous on a closed interval? Yeah, because our function is a what anomial? Polynomial. And it's continuous where? Everywhere. And we have a closed interval. So what you'd want to say in a complete sentence is something to the effect that is EVT does apply, or EVT applies, that's fewer words, since f of x is continuous. Now don't say for all real numbers. You want to speak specifically to the theorem itself. The theorem's if part is if it's continuous on a closed interval. So f of x is continuous on, and then say the specific closed interval. There you go. Now I know that I'm going to have both a max and a min, and it can occur at an endpoint or a critical value. So now we just need to identify the endpoints, right? And here's a door, here's a table with a green banana, and all of that is sitting inside this room. This is the room at the studio, the holding room. Yep, this is the green room. And who do we put into the green room? Who's already there ready to play the game? The banana is what they can eat while they're waiting. Yeah, team endpoints in there. Team endpoints in the green room, right? They're already there. They're already at the studio ready to play the game. We have the endpoints. They're going to be given to us, all right? Now, they can either eat the green banana or they can wait till later and eat the yellow banana. That's a Mitch Hedberg joke. Have you heard that one? Someone gave me a green banana. I was like, man, I don't want a banana now. And they're like, but I might want one later or a yellow one later. I don't know. He did it better than I did. We need to go out and find the contestants out of the critical values. I haven't slept for 10 days because that would be too long. That was another one of his. All right. Okay. So anyway, let's find the critical values. We take the derivative, which is 12x cubed minus 36x squared, and we look for critical values by determining where the derivative is one of 2 things. And the one that I told you students tend to forget is where it's undefined. We have a polynomial derivative. Is it ever undefined? No. So the only ones we need to look for then are where it's equal to 0. And once it's equal to 0, we try to factor it. And we succeed by factoring, in this case, by pulling out a 12x squared. And that leaves an x minus 3. Keep it equal to 0. So the solutions of that equation are 0 and 3. This means that these are the critical values that are in the domain of our polynomial. They're alive. They live in the town. But do they live in the precinct for which they're trying to run? Are both of them in the interval from -1 to 2? No. So sorry, 3. You just don't quite make it this time. We'll be coming to your area sometime soon. But 0, welcome. Welcome, 0, to the show. So now he's in the green room. And now we have team endpoint, and we have team critical value. And now the teams are uneven. Is that okay? Yes. It is, because in this game, it's not really about teamwork at all, right? It's not an aggregate score of your team. It's an individual effort. But maybe Team Endpoint has matching shirts and Team Critical Values feels left out. But you know what? If you're the only guy on the team, whatever shirt you're wearing, that's called a matching shirt with your teammates. All right, you ready? You ready to play the game? You ready to play the game? You ready to play the game? Who's ready to play Extrema? Hey! Alejandro's not ready. All right. Now, we're going to make this game suspenseful. We got people watching at home. We're going to find what f of -1 is, what f of 2 is, and what f of 0 is. Okay? This is how we actually play the game. Now, Team Endpoint, since there's 2 of you, we're going to let you go first. And so, Team Endpoint, you must decide which of you would like to go first, -1 or 2. So there. No, you go. No, you. Okay. All right. -1 decided to go first. So let's figure out what the function value is at -1. We'll plug it in up here into f. So I get what when I plug in a -1 for x? I get 3 plus 12, which is 15. Okay, 15. That's what -1 did. That's a very nice effort to start with. Kind of set the bar pretty high, right? I can see what Team Endpoint's strategy is. Go high early and put the pressure on Team Critical Value. Team in quotations. Just the one guy. All right, let's let Team Endpoint go again. So now they're talking to themselves. If -1 went high, a good strategy here if Team Endpoint wants to go for the sweep, and who doesn't, right? Go low, right? So they're coaching each other. Go low, go low. All right, so now it's 2's turn. You ready? Let's plug in a 2 up here. 2 to the 4th is 16 times 3 is 48 minus 8 times 12 is 96. 48 minus 96. -48. Whoa! The crowd goes wild. Nicely done. Now, the camera now zooms in on 0. The suspenseful music plays in the background. Is that a bead of sweat rolling down or a tear? Who knows? What's going to happen? The pressure's on. You ready, 0? Yeah. Let's go. What do you get when you plug in a 0? You get 0. Oh, boo. All right. So now we're at the end of the show where we anoint the winners. So we can say now that F has a max of what? 15 at x equals -1. So congratulations, -1. Yay, congratulations. Maybe you'll be back to play tomorrow on another episode of Extrema. F has a min of what? -48 at x equals 2. All right, yay. So by having the lowest score, you are also a winner. And unfortunately, x equals 0, Team Critical Value, you know, maybe you didn't have a shot because maybe you were outnumbered in the beginning, but you do leave with a broken toaster. Broken toaster, the official appliance of the NFL. Okay? That's it. Was that fun? Huh?
Do it again.
Air compressor? Oh, for the NFL. Yeah. No, I say that because I was watching on Monday Night Football the other night, and I kid you not, this came up. USAA. I love USAA insurance. I have it right now. I'm going through with them right now with a slab leak that I have, and they're a wonderful insurance company. But, and they're for former military, so they're for veterans. But it came on and it said USAA, the official, and you'd think they would say USAA, the official insurance company of the NFL, right? Even that's kind of silly because that's like, really? Now all the NFL players are going to have to get USAA? I don't think so. So here's what it says. USAA, the official military appreciation sponsor of the NFL. Did you know there was such a thing? Like the NFL is out soliciting for official military appreciation sponsors, and USAA won the bid. Jiffy Lube and Meineke Muffler and Jimmy John sandwiches must have lost out. I don't know. It's kind of silly.
I heard about that on the news, like all the veterans
It is. They're paid to be there. Yeah, so USAA is putting out the money. I think that's what that means. But it's kind of silly when it gets to that level, don't you think? Like, pick a random business.
Stanley Steamers.
Stanley Steamers. Carpet cleaner. Pick a random product. What? Hair gel. Okay. Stanley Steamer, the official hair gel appreciation sponsor of the NHL. Pick a random sports league. Yeah, it's like Mad Libs. It's like Mad Libs. Nothing against USAA, but I kind of feel like left out. Like every time you're watching an NFL game and you stand up and do the Pledge of Allegiance, you have to pay royalties to USAA. They're the official appreciation sponsor. Anyway, let's play the game again. This time I'm going to let you play it on your own. So this is where you'd be playing at home. Determine if the EVT applies. If so, find the extrema of this function on this interval. We're going to take this one to the bell, okay? You go, I go. I'm going to do it up here quietly in the background, and we're going to compare answers when it's all said and done. This would be like a long Jeopardy song playing in the background. Nope. Hypothetically. All right, there it is. I got it all worked out. We'll go over it after lunch. So have a great lunch.